All right, so we're on day 3 notes, and this is our day 3 warm-up. And it says solve for x and express as an exact value. And this is actually what we're going to get into today. So you're going to need a little guidance on this stuff. But right now, they want us to solve for x. Well, I don't know how to solve for that x. I don't know about you. But I do know that when we go from log form to exponential form, sometimes we then know how to solve things, okay? And these are equivalent to each other. So you can switch between the two forms anytime you want if you don't know how to solve for x where it is in the equation. So if you're in log form, put it in exponential, and sometimes then you know how to solve. If you're in exponential and you don't know how to solve it, maybe it needs to go to log form. And so you'll gain that instinct as you do more and more problems, okay? So right now, solving for that x, no clue. So what I'm going to do is I'm going to go from log form and I'm going to go over to our exponential form. So when we go to exponential form, we have to first locate our base. And remember, our base is our subscript, and that's the number 4. Then we need an exponent, okay? And in log form, your exponent is after the equal sign all by itself, and so our exponent is -5. Equals, the last thing we need is the n when we're in exponential form, and notice that the n is right next to your subscript, which is x. And so now if I gave you this equation instead, would you be able to solve for x? Of course you would be. All right. In fact, if you want to do it by hand, we would say x equals 1 over 4 to the 5th. So we get rid of the negative exponent. And then 4 to the 5th is actually 1,024. And so we end up with 1 over 1,024 as our value of x. And that one's finished. Okay. In this next one, it says solve for x. So again, x being down in the base, I don't know how to solve for that. So because we're in log form again, if we go to exponential, let's see what happens. And so in exponential, the first thing we need is that base. And remember, the base is the subscript, which here is our x. So we're going to write x. Now in exponential, we need our exponent, which is what a log is equal to, which is 2/3. And then in exponential, we need the number, which in log form is right next to the subscript, which is 81. And so now we're going to look at this thing and say, now can we be able to solve for x? It looks a little bit easier than the form it was in. And if you remember using your reciprocal power, we could go ahead and remove that 2/3 using our reciprocal power of 3/2. However, remember, you got to raise both sides to the reciprocal power. Why this works is that these exponents raised to an exponent get multiplied, and when you multiply 2/3 times 3/2, you end up with x to the first power. And x to the first power is really just x. On the other side, when you type in 81 raised to the 3/2, make sure your 3/2 are in parentheses if you have one of the older calculators. All right, you should end up with 729. Now there is a little something that we have to talk about technically, because this is an even number on the bottom. Technically, it should be positive and negative 729. However, bases in logs cannot be negative. Okay? They also cannot be 0, which we haven't talked about a whole lot yet. And therefore, in logs, we can't have the negative, and so this would end up getting rejected. And we would just say our answer is x equals 729. All right, so a little something, and we're going to practice and work on those today on day 3 notes. So I will see you guys there.